On this episode of Star, we will be looking at planet HD 119130b and its host star HD 119130. Before digging into the numbers, we must first look at how it was discovered. Through a process called transit photometry, which is the observing of the periodical dimming of a star, this host and its planet were discovered and analyzed. Because the planet passes in front of the star at fixed intervals, it can be concluded that it is traveling in an orbit around the star, and lots of information can be found because of this. The first topic we are going to look at is Newton's law of universal gravitation. As we have learned throughout our episodes of Star, things in space are measured in comparison to what happens in our own solar system, mainly between the Earth and the Sun. With that being said, let's take a look. As you can see, Newton's law of universal gravitation is F equals G times m1 times m2 over r squared. In this case, G is the universal gravitational constant, which is 6.67 times 10 to the negative 11th, m is the mass of the planet, and m2 is the mass of the host star, and r is the distance between the center of the planet to the center of its host star. Next, we must convert the data NASA has kindly given us into metric system units so that we can make this information useful. The mass of the planet is given as about 24.5 Earth mass, which we can convert to kilograms. We know the Earth's mass is 5.972 times 10 to the 24th kilogram. Therefore, the planet is about 24.5 times that size. Similarly, the star's mass is given in sun mass, which is the mass of the sun our Earth orbits. Knowing this mass is 1.989 times 10 to the 30th kilograms, we know that our star's mass is about that same size, one sun mass. We next need to find the distance between the center of the planet to the center of the star, which is given to us in astronomical units and is called its semi-major axis, talking about its orbit. One astronomical unit is equal to the distance between the Earth and the Sun, which we know is 1.49 times 10 to the 8th kilograms. HD 119130b's semi-major axis is about 0.13 times that, so we can therefore find its R value in kilometers. Finally, after finding all of this information, we can plug these values back into our equation and find the force in newtons of HD 19130 on HD 119130b. After having found these conversions, it makes it very easy to find the acceleration due to gravity on the planet itself. All we need to find is the radius of our planet, and we will be able to find this value. By converting the measure from Earth radius to kilometers, we can find our radius. Next, all we have to do is modify Newton's law of universal gravitation so that we are only looking for one mass instead of two. After we plug in our known values, we will find the acceleration due to gravity, which is 30.8 meters per second squared, about 3 times that of Earth's. The final value, and an important one we are going to want to determine, is its instantaneous velocity, or basically how fast it is orbiting its star at any given moment. We can find this value by using the formula for the circumference of the planet and dividing that by the amount of seconds it takes for our planet to orbit its star. As we know our R value already, or its semi-major axis, all we need to do is convert its orbital period from days to seconds. Using simple conversion factors, we can easily find this value and plug it into our formula to find that our planet orbits its star at 82,638.21 meters per second. Now, we have learned a lot about planet HD 119130b and its host star, but how similar is it to Earth? It is significantly larger than Earth, about 25 times its size. It has a much smaller distance to its star, about 1/10 of Earth's distance to the Sun. It takes the Earth about 365 days to orbit the Sun, while this planet takes 16 days. Its surface gravity is about 3 times that of Earth's, and its density is 7.4 grams per centimeters cubed versus Earth's 5.51 grams per centimeters cubed. Therefore, it is most definitely not an Earth-like planet. Finally, what would life on this planet really be like? This planet is known as a sub-Neptune planet, or one with a much larger mass than Earth, but not quite the mass of Neptune or Jupiter. Sub-Neptune planets have thick layers of rock, ice, or even sometimes liquid oceans. The planet Hoth from Star Wars may even be similar to our planet we have here. Although the telescope can't see it, there's probably a battle going on right now. Thanks for watching this episode of Star.